And this is why the notion of epsilon zero is important. I did not see you. Hello there! You just caught me on reading this thick book on proof theory to my carnivorous plants. Do not mind the raven. It's here to make sure that the plants are paying attention. They have an upcoming exam quite soon. My name is Pawel Pawlowski. This is how you spell it. I'm a postdoctoral researcher in logic at Ghent University in Belgium, but I'm also informally associated with LOPS research group at the University of Gdańsk in Poland. One interesting fact about me is that I defended my PhD thesis back in 2018 during the Star Wars Day. As for my logical as I was saying, my logical interests focus on applying non-deterministic semantics to various philosophical problems. Currently, I work on applying this semantics to modal logic, and this is the topic that I would like to present to you. But first, maybe let's go to a safer place than this zombie-infested bunker. Welcome back. Since now we are in a safer location, we can continue the video. We start with the notion of non-deterministic semantics, but in order to define it, we first need to say a few words about many-valued logics in general. Assume that we are working with propositional logic and we would like to consider an implication if P then Q. And suppose we want to calculate the value of implication given the values of P and Q. So if both of them are true, then the implication is true. Implication is false only if P is true and Q is false, and it's true in all remaining cases. Right? The next thing that we could do is we could define the notion of propositional tautology by saying that phi is a tautology if and only if for any valuation v, the value of phi is 1. This is actually enough to define a logic. Right? So first we need to define the set of values. Second, the interpretation of connectives. And the last piece is the set of designated values. These are the values that behave as 1. So these are the values that are actually used in the definition of a tautology of a given logic. Right? To give you a toy example, consider a three-valued logic where you have false sentences, true sentences, and nonsensical sentences. And assume that the only value that is interesting to us is 1. So this is the value that we like to preserve for under being tautology, right? So we can consider a following truth table for implication. Further assume that for classical values the implication works classically, and any combination of sentences involving nonsensical sentence gives you nonsensical sentence. Then the truth table looks like this. And this is actually how you can define a many-valued logic. So a non-deterministic semantics is actually similar to the semantics that we presented for many-valued logics, with the exception that functors or connectives in the language can give you a non-empty set of values as interpretation instead of a single value. Consider again the case of implication, right? Here we have 1, here we have 1, here we have 1, and here we're supposed to have 0, but instead we have 0 or 1, so we have a set of values. So this is a non-deterministic semantics. What does it mean for, let's say, calculating the value of the implication if we have the values of P and Q? It means that if P has value 1 and Q has value 0, then there is a valuation where the implication is true, but there is an additional one where the value is 0. So this means that the compound sentences do not uniquely determine the value of the complex sentence. The most popular semantics for modal logic is possible word semantics, also known as Kripke semantics. Instead of valuations here, we have models that contain three components. There is a non-empty set W of words. There is a binary relation R defined on W, and we read W1 R W2 as W1 sees W2, or that W2 is accessible for W1, and there is V valuation that tells us how propositional parameters behave in a particular words. Note that since the non-modal vocabulary, so implication, negation, conjunction and disjunction, are extensional, this is actually enough to tell us how non-modal vocabulary behaves in a particular word. We still need to provide the truth conditions for formulas box P and diamond P, or in general for box phi and diamond phi. So in order to do that, consider a simple example involving two possible words, W0 and W1, and suppose that W0 sees W1, and that we consider two propositional variables P and Q, and that P is true here and Q is true here, right? Then we say that diamond P is true at word W0. Notice that it is that the truth conditions are always relative to a particular possible word. If and only if there is a visible word, so that there is an arrow going from W0 to somewhere where P, or the thing that is in scope of the modal operator, is true over there. So in this example, diamond P is not true. Why? Well, because the only visible word is W1 and there is no P here. Box P is true, on the other hand, if and only if in all possible worlds that are accessible from a given possible world, the formula in the scope is true. So for instance here, formula, let's say, box Q is true since the only accessible word from W0 is W1 and Q is true here. This is actually enough to define the notion of modal tautology. Formula phi is a modal tautology if and only if, for all models, in all possible worlds, the formula phi is true. Now, in order to get modal logics by non-deterministic semantics, we consider a semantics where we have four values. Capital T, that means true and necessary, true and necessary. Small t, which says contingently true, so true but not necessary. F, which stands for contingently false, or false but not necessarily false, and capital F that says necessarily false. The remaining steps are to select the set of designated values, so in our case it's going to be capital T and lowercase t, which means that the set of non-designated values that we will denote by overline D is going to be small f and capital F, and the last part is to provide the interpretation of the functors of the language. We will focus only on negation, implication and box. So for negation, consider the following truth table. So we have capital T, lowercase t, and similarly for F. So if phi has value capital T, the negation of it has all non-designated, similarly here, and here we have all the designated values. Right? This means that negation simply flips the values. As for modality, consider the following. Here we can get the set of designated ones and here non-designated. The last part is implication. which is defined by the following. So we have t, small t, f, and capital F, and similarly here we have t. Oh Jesus, I'm so bad at drawing, sorry for that. Lowercase t, f, and f. Perfect. Right? So simply here, if we have, if the antecedent is designated and the consequent is not, we just simply get all non-designated values. The tricky parts are here where we get t, and here where we also get t. In the remaining cases we get capital D. So we have the set of all designated values. And this actually gives us a logic that is called t minus, which is basically the same as logic given by the Kripke models, where R is reflexive. So this means that we have box phi, then phi, but the minus stands for the lack of necessitation. So we don't have the rule that if phi is tautology, then box phi is as well. Right. So this means that actually by using non-deterministic semantics, we arrived at a modal logic that is weaker than the weakest modal logic that we can define by using possible word semantics. The same trick can be applied to even weaker logics, like the ones that do not validate the axiom responsible for the reflexivity of the relations of box phi and phi. But the question now is, can we actually get back the necessitation? And the answer is positive. In order to regain the necessitation, we need to consider the strengthening of the non-deterministic semantics that we gave by means of mth-level valuations. So, the intuition is as follows. Any valuations is level 0 valuation. Now, a valuation is level 1 if for any tautology on the previous level, so on level 0, this valuation ascribes to this tautology value capital T. So basically, for all tautologies, we get rid of the value small t. And then the valuation is at second level if it does the same for the things that are tautologies at the first level. And now we say that a valuation is mth level valuation if it is n level valuations for any n. So basically we repeat this procedure at infinitely many times, and the things that we are left with are the mth level valuations. Logic T minus is not the weakest logic that you can get. For instance, you can get logic K minus, so the logic that you get if you consider all the possible world models, but is not closed under necessitation. But the price to pay is, however, quite high. So instead of using 4 values, you need 8 of them, where 4 are designated and 4 are not. And you need to slightly change the definition of mth-level valuation if you want to regain the necessitation. So it seems that non-deterministic semantics is quite good at describing modal logics, especially if you are interested in logics that are slightly weaker than the logic that you get by using possible word semantics. For whatever philosophical reasons, if you believe that necessitation is not valid, then this might be a semantics for you. And this is where I would like to end the video, and thank you all for the attention. Let me end this video with a funny joke. So Tarski and Lindenbaum are sitting in a bar and they are drinking banana juice, as one usually does in such a situation, when Tarski suddenly says, "You know what, Lindenbaum? Every particular joke is omega consistent." And Lindenbaum looks at him and replies, "Seriously, but Gödel knows one that is not. But psst. This joke is actually funny because